Welcome, everyone, to the Horses and Humans Research Foundation Webinar Wednesday. We are very excited and pleased to be joined tonight by Dr. Stephen Peters, who is the author of Evidence-Based Horsemanship, along with Martin Black. I'd like to make an announcement before we start, and that is that if you look in the chat, you will find that HHRF has opened its grant application cycle. This is the largest grant, I believe, Molly, correct me if I'm wrong, that HHRF has ever offered. It is for $150,000, up to $150,000 for research on horse-human interactions that includes research on the horse. There are no further restrictions. We have had in the past looked at trauma in particular over the last few years, but we, in response to many of you and researchers, have decided to make this an open call. They are due on July the 8th. So these are for academic research pursuits, and you can, we do fund internationally. So some of you just already messaged, is it available in Canada? We have funded in Canada in the past.
3 times.
We have 3 in Canada, and we actually have 1 open in process in France at the moment. But I don't want to take a lot of time. I really want to turn the floor over to Dr. Stephen Peters and thank him for his time in presenting here, as well as thank each of you. You are the largest group that has ever signed up for Webinar Wednesday. We had to expand our Zoom capacity, and we appreciate each of you that made a donation, because that's part of how we fund those big grants. Thank you. Every dollar counts. Dr. Stephen Peters, you have the floor.
Okay, can everyone see my screen?
Yes.
Great. Well, I am delighted to be working with Horses and Humans Research Foundation. I think that pseudoscience and living in the age of misinformation has us all pretty confused. And so looking at what really is evidence-based information is important. So first of all, I'd like to tell you that don't go to Google U if you're looking for information. And artificial intelligence is really adding all kinds of stuff out there. Go to Google Scholar, go to Science Direct, go to PubMed, where you can find these peer-reviewed scientific studies. So for all of you who don't know who I am, I won't spend a lot of time on the introduction. I'm a clinical neuroscientist. I'm retired, but my job for over 3 decades was basically assessing brain functioning, and I ran big hospital-based clinics, a clinic for brain health and a memory clinic. And also with, I'm not unfamiliar with research. I was on a number of research clinical trials with a large neurology group. So I always looked at evidence-based approaches, and not only with humans, but I'd look at all the animal research, particularly horses, because I had horses. And so that really fascinated me to try to get an understanding from a neurological standpoint and to find information. And it's not easy. In fact, oftentimes studies are not double-blinded. They're not placebo-controlled. They end up in journals that aren't peer-reviewed. And so it's very hard oftentimes to find good information. But that was what I did. And I started dissecting out horse brains because I knew brains really well. I'd done a lot of dissection of human brains. So as I dissected out horse brains, I looked for various connections and to see how the whole thing worked. That was kind of my way of looking under the hood, so to speak. And word got out. So I was asked to go to scientific conferences, even though my background professionally, my day job was, looking at neuroimaging, et cetera, with humans. I sort of got a reputation of knowing the clinical research out there related to equines. So I got asked to go to veterinary groups. I was surprised. A lot of veterinarians, and it makes sense, don't get a lot of neurology. Basically, in the past, if it was a neurological problem, likely that horse was going to be put down. You weren't going to spend all that money on expensive diagnostic tests. Well, I've always had about 6 or 7 horses, and no matter what I do with those horses, it can't generalize out into the population of horses. The sample size is not big enough. Even if I ride and work with all my neighbors' horses, which I've always tried to do in the past, that's still a very small number. So my sample size, because in science, you can't say anything unless you have numbers behind you, large numbers. I would see studies, maybe 5 horses that were thoroughbreds, all kept in stalls, all fed grain. And then you did something with those horses and thought that number could then generalize out to the horse world, which isn't so. Basically, what I needed, and here's the scientific formula if you need to go tell your spouse why you need more horses. The larger sample you get, the closer you can say something about the whole population. But I didn't have 150 horses in my backyard. Well, this fella did, Martin Black. And so he's a 5th generation cowboy. His family's always worked with horses. He has seen thousands and thousands of horses. He's been to the racetracks. He's worked with horses in dressage. He's worked with Mustangs. He doesn't treat any of them any differently. He knows they all have brains. And so what I got from Martin was what's called in science, an important part of the scientific process is empirical data. That's observations, lots and lots and lots of observations. And Martin came from good stock. I don't know how many of your listeners tonight know who Ray Hunt is. That's Martin Black's father-in-law. Martin ran a big ranch, the Gamble Wine Cup Ranch, 1 million acres. So he had lots of horses, lots of cowboys, and had to get a lot of horses started. And so this little diminutive man here helped Martin out and would come up to the Gamble Wine Cup Ranch. His name's Tom Dorrance. He's another name in the early, what they used to call natural horsemanship circles. But Martin himself was a good scientist. He had good powers of observation. He wasn't in it to show off and have a big ego. He had questions galore. And so basically, he came to my lab, and I actually, when he was there, I had an MRI machine, so I stuck him in there and took pictures of his brain as well. So Martin would come and he'd learn the science, and then I would go back to Martin's lab and we would ride and actually we worked cattle as well. So we were trying to understand the cattle's nervous system and how they operate as a group for low stress cattle handling, as well as low stress work with horses. If you look at my hat, I have a GoPro up there. We filmed everything we could. So we would ride out there and look at horses, and like an ethnologist. So those folks in the field study horses. Now, these were domestic horses that were just out running loose. It's not the same as studying wild horses, but studying large numbers of horses nonetheless. This woman, Kim Stone, she's an award-winning photographer. She came out there with us and captured thousands and thousands of images. And then at night, we would look and I'd say, you see that facial nerve, how that's just sort of poking out like a guitar string in that horse's jaw? And Martin would say, yeah, when this happens, look how wide their eyes get. And so we would share data back and forth, empirical evidence from observation and the science and the neurology to back that up. So it was like putting puzzle pieces together. And the cool thing about that was how well all the pieces fit together. So we decided to write a book, The Cowboy and the Scientist, and we wrote Evidence-Based Horsemanship. Now, one of the things that makes it difficult for us to learn and trust science is we have to recognize our own biases. So oftentimes there's something called confirmation bias. So we're willing to accept those things that agree with us, but turn our back on facts and evidence that don't necessarily coincide with our belief systems. And we do this subconsciously. So we need to be aware that of why are we not accepting of information? You should be skeptical. You should have critical thinking. But if it's an emotional reaction to something, oftentimes that's shutting the door on new research, it may be something in your past that's leading you to think that way. This can also cause what's called cognitive dissonance. Cognitive dissonance is when you hold a belief so firmly. In fact, your identity may be caught up in your belief. For example, let's say your grandfather was really rough with horses, but you loved your grandfather, and that was your introduction to horses. So let's say now you're learning different ways of being with horses, giving horses a say-so, understanding their nervous system. You may feel almost guilty about the feelings you have now towards your grandfather. So you may find that you just shut the door on things. You say, either I'm going to open up and feel uncomfortable for a while as I accept this information, or that's a bunch of baloney, and close the door on it. So not only is it hard enough to get good information, also our own biases, beliefs, experiences, the crowd we hang out with can also impact the way we look at information. And we just need to be aware of that, because we create our own narrative stories, and then we try to look for information to match that narrative story. So how do we find good information? Well, here is the hierarchy of scientific evidence. Interestingly enough, if you look at the very bottom rung, it's expert opinion. So that's what a lot of people, go by. Case reports would be, you follow a horse and maybe you take lots and lots of notes, and then you could present a case. This is what's going on with this particular horse. Cohort studies are where you're starting to study groups of horses longitudinally over time. Here's what we don't have enough of, are randomized controlled trials. If I have 100 horses to pick from and I don't randomly assign them, I just go to the barn and say, go to the pasture, I'm taking these 5 particular horses because I know when I do X, Y, and Z with them, they will do A, B, and C and prove my research correct. So you can't cherry pick the best horses. Maybe what you do is go out and go 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, all the 2s go over here, all the 3s go into a control group. And you should be blinded. You should not know who gets the sugar pill and who doesn't. And a lot of studies, the experimenter themselves knows exactly what they want to show, and they're the one who's actually running the whole operation. And that can create some bias. Up at the top, we have systematic reviews, what we call a meta-analysis. Here's what that would be. And we'll look at one tonight. What you would do is you'd look at all the peer-reviewed scientific literature out there for something like cribbing. So you get all the literature you can for the last 20 years. And if you start to see trends in there, hey, this study was done with Pasafinos, and this one was done with Mustangs, and this one was done with draft horses. And you look at all those studies, and actually they can be easily replicated, and they keep getting the same results over and over and over and over again. That's basically our gold standard. So evidence-based approaches are approaches that use scientific data from the top rungs if we can do that. And that's why I so strongly support groups like this who are concerned with doing research and getting good information. You know, people would tell me, you know, I'd ask, why do you do that, what you're doing right now? Because the research is actually showing something different. And they'd say, well, we've been doing this for 50 years, so we don't need to hear that. You can also do something wrong for 50 years. And so that's not justification to do something wrong for 51 years. It may be that, heck, if that's where what the research is showing, that may be worth having a look at. And I don't mean just one study, you know, getting closer to the systematic review where lots of studies reinforce one another. This is my website, horsebrainscience.info. So you can sort of go there and find out a little bit more about me if you're still curious, and see what events I'm involved in. This is a horse brain, an amazing structure. On the right is a human brain, big and puffy. And on the left is the horse brain. About one third of our brain is made up of frontal lobe. Horses have a frontal lobe. I don't know where this idea came from that they don't. All mammals have frontal lobes. Frontal lobes as well. Sometimes we are not clear about what we're talking about because there are actually about 25 subsections of the frontal lobe, prefrontal lobe, orbital frontal lobe, all involved in doing something different. So even something as general as saying frontal lobe is misleading, but we have a much larger and more sophisticated frontal lobe for sure. So this big yellow area, about 1/3 of our brain is made up of our frontal lobes. So what do we do with our frontal lobes? Strategize, plan, make contingency plans. So the horse is not, you know, watching one flake of hay that nobody else sees and thinks, I'm just going to kick it under this bush and come back on Tuesday, and maybe when no one else is around, then I'll eat that. So they're not planning ahead in that way. You know, they're not being disrespectful. That's an abstract term. That's language. You know, oftentimes if they're walking in our space, there's a reason why. You know, maybe we're sending signals that tell that horse it's okay to do that, or somehow inadvertently we've trained them to do that. But to call them names really is not effective and actually justifies punishment. And we really don't want to be turning to that in a toolbox. In fact, I don't think, you know, positive punishment has any role in learning. And the research would bear me out on that. Where we get in trouble is where we think the horse has a human brain. But think of this for a moment. Your horse does not live in your world, and you do not live in your horse world. I don't care if you go out there and whinny and kick up dirt and try to act like a horse. You live in two different worlds. What I mean by that, just take a look at their pupil, right? It's lateral. So they're cutting off the top of the vision and the bottom of the vision. It's like a huge panorama, like those old movies in the 1960s you'd watch on TV, and the top part's cut off and the bottom part's cut off, and you get this big panorama. That's how they see the world, and they don't see the same color scheme that we do. Right in front, they have binocular vision. So oftentimes they're trying to lower their head and get depth perception. So, when they're out running on rough terrain or their first water crossing, oftentimes what they're doing is trying to figure out the depth perception involved. So oftentimes when we're yanking up their head, we're not giving them the opportunity to actually do that. They don't see in the same color spectrum we do. They are dichromatic, we are trichromatic. So they see things maybe in this little yellowish greenish gradations of gray. White will stand out to a horse. They also have in their photoreceptors in their brain, in their eye, the photoreceptors in their eye, all these signals get put back together again in the occipital lobe. The eye is just a lens, but rods see very well at night. They increase light. Cones increase clarity and color. The ratio is much different. Horses have about 20-to-1 rods to cones. So their vision is somewhat blurry. They're not 20/20. People have said 20/30, 20/40, 20/60 in research trials. So they see a blurry world, unlike ours. It doesn't have the same color ours has, but they can see much, much better at night. If you're curious, in the human, it's about a 9-to-1 ratio. They move their ears independently. You can't do that. So the whole world, once it gets into the horse's brain and they process it, looks totally different than yours does. So when we try to think that they're experiencing the same world we are, we're already not accurate in our perception, in our relationship with our horse. We are getting very sophisticated. In fact, we're doing a lot of neuroimaging, MRI pictures of the horse's brain. So things we could never do before. In fact, in large veterinary neurology, neuroimaging is becoming more and more used, and also more powerful equipment. Here's a horse getting a CT scan. So we can get incredible images of the horse's brain. And this helps us with something called morphology. We're learning not just the structures in the organization, but how they all talk to each other. And what we're hoping is that eventually you could almost do what's called a functional MRI with a horse. There's a German group, Martin Schmidt, in a German group, are trying to move toward getting a functional MRI with a horse. Why would that be important? Well, a functional MRI is a neuroimaging device that takes a picture of the brain in real time. If you're reading a book, I can look at the scanner and I can see which areas of your brain you're using to read that book in real time. One of the big problems is something called motion artifact. You can't, move around. You'll blur your picture. So people would say, well, then sedate the horse. Well, the way functional MRI works is blood and oxygen rushes to the areas that you're using. So if you've sedated your horse, you're not going to have that same thing happening with their metabolism. But computer programs can rectify and change things. So there's a bold new future. And so where we used to interpret for the horse, I think we're getting to a point where the horse can almost tell us themselves, not through language, but through technology. And to me, I think that's a pretty exciting turn as we move in that direction. It can only help the horse, to be able to have a voice in all this. You can put EEG monitors on horses now, and you don't put electrodes down in the brain. You actually put conductive gel on little cups, and you just place them strategically, and you can see where you can read the brain waves in horses. So a lot of things that are around the corner in medical technology are really going to be fantastic. In fact, those pictures I showed you is what were taken with what's called a 3 Tesla magnet. That's probably the same MRI that you would get if you went to go see your doctor. So it's kind of a cool thing. I mean, long ago they would think, is the horse even worth this? And we're not even thinking about how the parts of the brain interact and speak with each other. I think we've grossly underestimated the intelligence of horses. We can't even define intelligence for humans, let alone horses. And then we give them human tests in order to find out supposedly how smart they are. Well, why can't we give them horse-related tests so that they can use their horse's brain to figure things out? And we may be more accurate. Our brains are live wired, and so are our horses. What do I mean by that? Your brain is like a snowflake. It's not the same as any one other listener listening in here. If I say the word horse, your pictures are, maybe you had a wreck with a horse. Maybe, your horse has always been in the barn and somebody else's horse has always been in the pasture. So every experience we've had wires our brain. We send electrochemical messages down neurons, and if we send enough of them, then they get wired together. This is called neuroplasticity. So you can get neurogenesis, you can grow new neurons, you can strengthen synapses, you can grow new synapses, you can get weakened synapses. If something's going on where your horse is always resorting to maybe rearing up and pawing and easily going to fight or flight, what we might want to do is weaken some of those messages, some of those passages, and strengthen others so that the horse doesn't have to feel like it has to go to that measure to respond. So basically, you can call it what you want. You can call it anybody's method, that's out there selling horsemanship. But no matter which package you buy, the brain is still going to process it like the brain. So understanding the brain, right, and optimizing how messages are sent through the brain and how they're processed and how the horse learns and how the horse maintains homeostasis, a biological balance, can only help. So I can call anything with language what I want to, but how the horse's brain takes that in is unique to that brain. Hebb's rule: neurons that fire together wire together. This is the principle of neuroplasticity in the brain. And what we're always doing, and hopefully this is going to happen to you tonight, what'll happen is you'll get some new information, and you already have a neural network, but you'll say, you know what? The things that guy said, that kind of puts a different light on this. And you know what? I've heard something like that, and that seems to make sense. And you go to sleep at night, and what happens is your brain keeps firing. A neurochemical called acetylcholine goes in and, like a highlight marker, marks all these neurons that seem to have things in common and wires them together so that your neural network is more sophisticated as a result of your brain learning, which is fascinating because this is a lifelong process for you and your horse. Myelin. Can't really talk much about learning without talking about myelin, because when neurons fire and you become really good at something, you don't have to know these big fancy words, but you signed up. So here's a couple of $10 words you get out of tonight's talk. Oligodendrocytes are cells that once a neuron fires, they get stimulated and they'll go and start to wrap that neuron with a fatty wrapping that insulates it called myelin. Myelin allows information. Here's an oligodendrocyte wrapping myelin around a neuron. You can get wrapping and wrapping and wrapping. If somebody becomes like a piano protege in areas of their brain that they use to play the piano, we'll find lots of what we call white matter, lots of myelin in there, and they'll be overwrapped. Why would we want to do that? Well, here's a neuron without myelin on the left-hand side. Messages travel over this neuron at about 2 miles an hour. Now, the myelinated neuron over on the right, information travels about 200 miles an hour, and we don't lose information. It's more efficient and it's faster. That's why people who become experts at things, when things start going really fast and get complicated and there's chaos, they always say, well, it just kind of felt like things slowed down and started to go in slow motion, because they're using these pathways that are so well used. The problem is, you can also myelinate the wrong things. So we want to be very precise in our communication with our horse and what we're doing with our horse, and allowing our horse to maintain homeostasis so that we don't wire in fight or flight. I mean, you can wire in fight or flight, where your horse gets scared about something and you're going to make them take it however they like. And, you just make them do something. And so that the next time you come back out, they're already sympathetically aroused. They're already nervous and afraid, because we've actually wired that in. So what you're hearing should make you feel very empowered, because you can be responsible for how your horse's brain grows. You can be responsible for how many neurons are connected and how sophisticated that connection is, and how many new dendrites grow and branch out. But you can also be abusive and you can trim those off. And so that horse becomes very rigid, and their brains don't weigh as much. Their brains don't have as many connections. And so knowing that you're able to do that in your interaction with your horse and setting it up to optimize your relationship with your horse and optimize their learning is really, I think, a pretty cool thing. These are neurons. Here's an electron microscopic picture of neurons all wrapped with myelin. So these are all messages in the brain that are going to travel at breakneck speed. And because of all that insulation, that information is not going to leak out. It's going to be efficient. Give you some examples of myelination. Horses, when they're first born, their motor strip and their motor areas myelinate first. That makes sense, because it takes us, 2-3 years to be walking and talking, just basically. They need to be on their feet quickly to survive. So every time that foal stretches, every time that foal jumps in the air, they're not thinking about it. I mean, that foal doesn't even know which direction it's going to go once its feet hit the ground again, but it just springs off like pogo stick in another direction. But over time, very quickly, it starts to myelinate those important pathways, and their movements become smoother and smoother, so that in almost no time, they're almost lockstep with mom. Even though mom has longer legs, you'll kind of see them both moving the same. So myelination of neurons is almost like creating an HOV lane for messages in your brain. Everything else over here is unclear. You're unsure of it. You don't have enough information. That's all this traffic over here moving slowly that causes a lot of noise. But the signal that you want is to try to get into the HOV lane. Now, I can't tonight, in a short amount of time, give you all the ideas of how to do that, but I just want you to know that this phenomenon exists. And I thought that because we're a research group, we would just kind of look at some research studies here. Because I want you to see that everything we talk about tonight really is evidence-based. So some of those that we're definitely going to look at is down towards the very bottom, the second one up from the bottom, Marty Seligman's studies in the 1960s were around learned helplessness. So if we get a chance, that's something that I really want you to know in interacting with horses, and oftentimes rescue horses that have gone into this learned helplessness state. Down at the very bottom, a selective role for dopamine and reward learning. There really is no study out there on learning that doesn't implicate the dopamine system. That's how you get rewarded. So that's why you're all listening tonight. You want to get your dopamine hit. You want to go, yes, now I got it, right? And so we're going to grow you a couple new dendrites tonight. You'll wake up in the morning with a more sophisticated neural pathway, right? Let's see some other studies. The hippocampus as a spatial map. The hippocampus, that's Greek for seahorse, because early neuroanatomists thought it looked like a seahorse. It's about even with your ear. Same with your horse. It runs right down here. It's inside the temporal lobe. The hippocampus is a spatial map. We'll get a chance to look at that research. And vibrissae, I'll read it first and then I'll tell you the English translation. Vibrissae resonance as a transduction mechanism for tactile encoding. Basically, vibrissae are those, what you used to call whiskers growing out of your horse's face that we now know are sensory organs. So the resonance of moving those whiskers across a surface provide sensory information to the horse. Another one that we might want to look at is at the very bottom here, looking at serotonin. That's a neurotransmitter. And I don't want to get too out there and too deep so that we lose people in the jargon. That's not the purpose. But I want to show you some really interesting things that the science can show us about horses. But that study is important because of learning trials, intervals between trials. And I think it's too ambitious to go any farther than that. I hope we're doing okay on time. I actually have a timekeeper who's going to let me know when we get to the last 10 minutes so that we can entertain questions. I'm sure you probably have a few. So what we used to call whiskers there are vibrissae. Not the hair, but when it reaches the follicle, it's attached to a structure that fires when that hair passes across something. Typically, they're in blind spots for the horse. Just a moment. I'm sorry about that. The UPS man arrived and my dog's barking. Yeah, real life invaded. So when your horse is doing this and investigating this saddle pad, they're not smelling it. Their olfactory bulbs can smell this far away, and they're rubbing their vibrissae on it. You've watched them on the electric fence. You know just how close that they can get, right? It's their way of saying, is this hot? Is it cold? Is it solid? Is it soft? Almost like you would handle something with your hands in an investigative manner. So here's an electron microscopic picture of a vibrissae, has its own blood supply, and it's set up in a topographical map. When they used to shave these, and hopefully you're not doing that anymore. In fact, I think the FEI has now outlawed in a number of countries shaving these vibrissae. Oftentimes what happens when we do that, you know, eye trauma increases. If you've seen horses like in an unfamiliar round pen and you shave those off, they seem to be banging their face against the panel because they don't have that in place. here's vibrissae in a sea lion. They've gone and put blocked auditory signals. They've blocked visual signals, and they'll throw a ball through the water, and just those currents, the sea lion can find that ball through its vibrissae. The military think this is great. So this is the same structure here you would have in your horse. You have these little whisker-like pieces hanging down. They have a, like where the hair follicle would be, that fires when this hair follicle rubs against something and then sends that message up topographically so robots can move through space and know where they're at based on the same thing that's going on in your horse. They're in blind spots. They protect the horse. Eye trauma increases, lip trauma increases when they cut them. Maybe that nail sticking out of the manger that they would have noticed before, they don't notice because we've taken away one of their senses. All right, we're going to look at a meta-analysis. You're not supposed to read this, by the way. I can barely read this, but we're going to talk about it. This is a meta-analysis. So it's in the Applied Animal Behavior Science Journal, a peer-reviewed scientific journal. It's a meta-analysis. So what they've done is over almost a 20-year period, they've looked at cribbing. So what do they find? Well, what they find over all these studies is that management plays a high role. Provision of high concentrate diets, abrupt weaning, and they think the dopamine system is involved, and also gastrointestinal irritation. I'm going to put this whole picture together for you. This used to be called an oral stereotypy. A stereotypy is basically a behavior that's supposedly done repetitively with no purpose. Here's what they found, is that it's an adaptive strategy, so that cortisol levels and stress levels are very high. And when the horse cribs, they fall back within normal limits. Let's take a look at this using all these pieces here. It takes a while to digest hay, 4 times longer than it takes to eat processed grain, which goes through you very quickly. It may have all the nutritional value, but it doesn't give you constant gut fill. If horses are just left on their own to wander in the wild, they produce gastric acid, about 1.5 quarts per hour. You know, they produce gastric acid. You don't produce gastric acid until you go eat a sandwich. It's like an on-demand system. They always have that gastric acid in there. So if they don't have constant gut fill like they're designed to have, what happens is once what's in their stomach falls below that level, then that gastric acid touches the inside lining of the stomach. And that's why a lot of domestic horses have gastric ulcers. So in order to create a bromide to coat their stomach so that they feel better, they actually try to bite on something so they can create a bromide to coat their stomach. They do to some extent, and it helps. But for some reason, their entire dopamine system gets highly sensitized to reward, so that the cribbing behavior itself creates dopamine. So it's like an addiction. They're getting their cocaine hit. They're getting their methamphetamine hit each time in the nucleus accumbens, a reward center in the brain. We know now that area gets really lit up with cribbers. So once it becomes an addiction, it's almost impossible to break. You put on a cribbing collar, which is pretty harsh treatment to give an electric shock to try to stop that. It really doesn't stop it. And actually, when you stop that behavior, cortisol levels shoot back up again, because the horse in an abnormal situation has found that it can maintain its own homeostasis. and feel better and reduce cortisol by the cribbing. So when we take that away, their cortisol levels and anxiety levels actually go through the roof. So is this a bad horse who cribs? Or is this because we put them in an abnormal situation that they try to adjust to? And certain horses are more prone to this than others, but it's not learned. I mean, the worst thing you can do is say, I don't want the horse to see, the other horses to see this horse cribbing. So I'm going to isolate this horse. Isolation and restraint are probably the two biggest stressors that you can put on horses. Isolation and restraint. So isolating them just causes even more of a problem. Cribbing. This is a key concept. Internal locus of control and external locus of control. External locus of control is where the outside world is making all the decisions for you, whether you like it or not. So you feel like after a while, it doesn't matter what I say. It doesn't matter what I do. It's still going to be this way. So this would be, I'm going to make my horse do these things. I'm not asking them. I'm not enlisting them in the event with me. I want to make my horse do these things. And you can do that. Or you can set things up for your horse to solve problems. And we know that their brains are much more sophisticated, have more neurons, have more neural connections if they're able to solve problems, if we give them choices along the way. So let's take a quick look at Marty Seligman's experiments that are relevant when we look at training horses, especially in terms of what's called flooding. So here's what Dr. Seligman did, is under or above this electric grid, he put a light bulb and he would light it up over A, and a few seconds later, deliver an electric shock to the electric grid underneath letter A. So the dog would quickly learn, when that light bulb comes on, I'm going to jump to B, and I avoid the shock. So cortisol levels came back down because the dog had an internal locus of control. I know that if a shock's coming, I can get away from it. And it would jump to B, light bulb comes on over B, dog jumps to A. Dr. Seligman then electrified the entire grid. Dog jumped from A to B to A to B frantically and could not get away. No matter what the dog did, there was no way to get away from the shock. So these dogs hovered in a corner, urinated on themselves, began to shake, were actually traumatized for life as a result of these experiments. I do want to say that Dr. Seligman was almost traumatized himself. So he actually changed what he was looking for and began to study how do we find happiness in animals, because this would traumatize me as well. And yet I saw, it must have been about 15 years ago, an article where somebody was proposing that we should train horses this way so that they're more compliant and safer, because they're not, wouldn't have any say-so. It's much like those old dude ranch horses that no matter what they do, they're going to get their lips pulled on, their mouth, the bits are going to bang their teeth, they're going to get kicked, and maybe all at the same time. So even trying to figure it out, so they just zone out and kind of like zombies are in another world as they sort of march off head to tail with a dead eye. These horses don't even seem alive. They've gone somewhere else. And we certainly don't want to do that with our horses. Somebody might ask you, well, what fascinating fact did you find out in your listening to the webinar? So let's give you a fascinating fact. I talked about the hippocampal map. And this is based on the research of John O'Keefe. He was a British scientist, and he put electrodes in the brains of rats, ran them through mazes, and what he found was, gosh, here one neuron fires when this rat is in a specific location. And now another neuron fires but it's not the same neuron. It's a different neuron, but just one when the rat's in this other location. And what he was finding was what are now called place cells. So the rat would sleep at night. These neurons would fire in reverse order. And so the rat could almost follow this trail in its brain based on these place cells that its brain created. Then some Norwegians, the Mosers, a married couple, did research and found out, holy mackerel, these place cells are actually in a grid system, longitude and latitude, so that when you lay down these place cells, they're a GPS map. Both of them together. Well, here, I'll show you the hippocampus. So this would be a structure of the brain. This would be the temporal lobe. This is a model. If I took it out and sliced the top off, and I'm looking down in, so we see that numeral 8, that structure there, let me see if I have a pointer. Right here is the hippocampus. That's where these place cells are being created. An interesting thing, just by the way, I'll show you. This structure here that looks like an almond is the amygdala, and that's related to fear. Now, if you want to think about how would a trauma occur, well, gosh, we have the amygdala here that's related to fear, and it's almost attached to the hippocampus, meaning we're creating memories that we can't forget. That's what flashbacks are, just these memories that are so real because they're etched in. So this is why we want to be so careful about putting that etching into our horse's brain and traumatizing a horse, because these are rehab situations. We have to now try to rewire this whole thing and get the horse to trust and not activate the amygdala to set this whole cycle back off again. But that's where the hippocampus is located. And don't believe anything I say. You can look all this stuff up. The John O'Keefe and the Mosers, they actually won the Nobel Prize in medicine in 2014 for their findings. Later on, we found there's boundary cells. There are head direction cells. So what your horse is likely doing is not saying, I'm going to take a left at the silo, and then I'm going to go down to that old corral, and then I'm going to hang a right and head out to the pasture, almost like a Geiger counter. Your horse can follow these place cells. So if you're in the dark, if you've been away from the trailer one time and you get sort of disoriented, it might not be a bad idea to see if your horse can find the way back, especially if it's at night. They got a 20 to 1, they got a 20 to 1 rod to cone ratio. So they're seeing with more light than you see, and they've laid down place cells that can get them back to where they were before. But we could always take over and intervene and get in the way. You may ask, and I'm sure this question will come up, do humans have these place cells? What they found is in London cab drivers who just continually learned this really notorious test, used to take 2 years to pass, where you would have to visualize where all these places were and know where they were. And the failure rate for this test was, really astronomical. So they could do like virtual reality and hook these cab drivers up and ask them to go someplace, and they'd find these place cells firing in their brain. But when the cab drivers started going to an electronic GPS system, they didn't have the same place cell. So technology is kind of taking that over for humans, but it comes standard feature with your horse. How are we doing on time? Well, I'm just going to keep going until somebody.
We are actually, Dr. Peters, we are at 7:56, and I wasn't watching the time, and I'm not sure who was supposed to. So if you want to say a few words, and then we can go to questions. And my apologies for not giving you better timing.
No,
the
that's
horse.
fine. And in fact, maybe you'll have me back sometime in the future and we'll just pick this up.
You're invited.
And we
Consider
can go
yourself
even
formally
deeper to
invited.
this, or you could go to my website and see where I'm at. I do have seminars that are actually almost 3 days long, where we actually demonstrate these things with horses. But in the little amount of time we have left, I'd like to answer some questions if somebody has some burning questions before we sign off.
Kathy, I'm going to kick it to you.
Yeah, so so really quick, link to the website, link to your book, a link to the research articles, those were requested. And then yes, have them back. This is fabulous. But the hard questions were, do you have recommendations for addressing heavily myelinated neurons? For example, working with an older horse who has an ingrained habit, which you kind of addressed with the cribbing.
That's a good question, and the age may be different, and so some of these things might not go completely away. So what you want to do is work out situations so that they get rewarded, and not try to drill it, because it took years to create that heavily myelinated pathway. So when your horse first starts to get it, trying something a little different, that's the time to take the break and allow that information to slowly get consolidated. We get greedy and we try to do too much at one time, and it's counterproductive. The information just doesn't consolidate or get assimilated into the horse's brain. So step by step, slowly, and make sure that you reward when that horse seems to have gotten the information. Reward can be getting out of their space altogether. Now, we might think, oh, reward is I'm going to hug my horse. What we often find out is that actually interrupts the process. We want that brain to replay what they've done. So slow and gradual, and give your horse plenty of breaks. Look for licking and chewing. I didn't get around to why that's important, but that's a good indicator for you that the horse is dropping back down, if they've been sympathetically aroused, back into a more parasympathetic state. And let them process information, look for that eye blinking, etc., and go slowly. And what you'll do over time is create new pathways. But like I say, the older the horse, the more difficult it is. What I would say is for you to be patient. It's going to take time. Recognize it's going to be patient, and be creative in setting up new pathways, and give your horse an internal locus of control. Instead of making them do something, give them some choice where they get a choice to choose something different, alternate than what they did before, and allow them some say-so, and you'll start to create brain changes. Hopefully that's helpful.
Definitely. Another question, have you been involved in interaction of the horse head brain with other neurological centers like heart or gut brain that interact with one another but exist independently in humans?
You kind of broke up there. Can you repeat that again? Is that 1 or 12 questions?
Have you been involved in an interaction of the horse's head brain with other neurological centers like heart and gut brains that interact with one another but exist independently in humans?
That's a question that would take a lot to say, but basically I can say this. You really get nowhere, or you get a limited understanding, if you carve up the whole system. And that's been a problem in medicine for a long time, where we just look at the symptom without understanding how it plays out in the whole system. There's some areas we didn't get to, like the basal ganglia that has loops. There's a cognitive loop, a sensory motor loop, a limbic loop that are all intertwined in a system. So I've always looked at medicine and science and the human body and mammals and animals as a biological system. So I know what you're saying, but I don't know that we have the time to really dive in there. But I can give you, let me give you those links. Horsebrainscience.info is my website. You can also go to evidence/based horsemanship.com is another website. We're in the process of actually, when we wrote the first book, Evidence-Based Horsemanship, we made a decision that we wanted it to be very readable. And although we had tons of research, the research was bigger than the whole book. So we chose to leave that off. In fact, Martin said, I want some cowboy to pull this out of his saddlebag, be able to sit down around the campfire and actually try to work his way through this. And they're not going to do that carrying a big tome out there, and we'll lose them. We are revising evidence-based horsemanship, doing a second edition, and all the research, and that's why I pulled up some of this here to share with you. All the research and all the newer research is going to be part of our citations in the new book. So be looking for that. And even if you don't buy the book, you can go to the library and look at the citations in the back, because it's going to be chock full of studies. I think we have to have that now, because if we're saying we're evidence-based, we really have to support that information, so that a lot of what's floating around out there that's misinformation, that's information that's been crafted without any scientific support. And I don't want to turn you against science. You know, science has not done the best job in some of its studies. And I look at some and I scratch my head. And then some of the comments that come out, we can read the horse's brain. We can read their mind, you know, and then I go and I look and I find they put EEGs on. Well, heck, we've had EEGs forever. We've stick them on humans, you know, to look for epilepsy, etc. So sometimes these things are not new, but they get sensationalized. So hopefully groups like this and providing you with peer-reviewed scientific citations and references will help answer a lot of questions. So I didn't get to look at a lot of these studies. I would have liked to, but be on the lookout for the new book. It should be out at the end of the year, and many of the citations that we talked about tonight will be a part of that.
So Dr. Stephen Peters, thank you so much for such an incredibly informative evening. I would like to try and plan part 2. And so I know you will be hearing from us. There's so much in your book and in the questions. We have great questions. We can certainly try and answer a few more of those. I apologize for the bouncing. My dog is scratching me. Not well trained and probably over myelinated. But if folks are willing to, and if you have a few minutes, I'd love to try and get to a few more questions if you're up for that. And we certainly recognize that people have other obligations. It's and given where people are in the world, it might be 2 o'clock in the morning or 8 o'clock in the evening. But Kathy, if you're able to just continue to pitch a few questions, let's go for a few more minutes. And again, say thank you so much to our
guests. I do want to mention that you are all scientists, you know, all your observations are valid, you know, so basically ask your horse, right? Go out there and interact with your horse and ask your horse and try things and see, well, how do they react when this happens? So bear that in mind. Give yourself the power to have confidence in your own observations. So, okay, let's do a few more questions and we'll call it a night.
One question is, what do you teach in your evidence-based horsemanship virtual clinic?
Ah, good question. Yeah, you can go to martinblack.net. We have a virtual clinic once a quarter, and we look at all kinds of issues. So we might just take one issue. For example, maybe we'll look at pain. Maybe we'll look at, one time we did what was called the director's cut, and Martin and I handpicked like 3 or 4 things that we thought were most important that people in the horse world should know. And if we're limited to just a few very key points, we'd go over those in a virtual clinic, his and mine, and discuss them. So what we do is we choose a topic. Actually, the topic for the next virtual clinic coming up is the evidence behind evidence-based horsemanship. So we're just going to dive in and do a lot of studies just like we did here, but we'll do them one at a time and over a 2-hour period. And so if that's your cup of tea and you didn't quite get your thirst quenched by what we touched on here, we're going to be looking at some of the research behind evidence-based horsemanship. So that's what the virtual clinics are, is one topic that we can deep dive on.
Here's another question. Is there a resource that would make the information presented help emergency first responders better handle horses during emergencies?
I think understanding their nervous system and when they're sympathetically aroused, parasympathetically aroused, and sometimes in your best efforts to come charging in, to come running in, and a lot of times you often see those horses just take off running, and then they're lost and you have to go find them. So, if you approach the horse slowly, and maybe if the horse started to move somewhat and you tried to match their steps without coming right towards them, and you tried to connect in ways that were reassuring. One is actually also, if they're going to fight or flight, there's really no point at trying to teach them anything. So outside of what's benefit to the horse, knowing when the horse is in that state, how not to exacerbate it. How do you exacerbate it? Restraint and isolation. So sometimes, if you're getting horses out of a fire, for example, it might be better, to get them moving out of the stalls together. Certainly to just let them move their feet oftentimes is enough to allow them to go back to the homeostasis. So movement can be a calming signal for the horse. So sometimes you'll see some emergency responder might arrive, they've got the halter on, they've got the horse right underneath the chin and trying to get the horse to stand still. And that restraint alone just sends them more sympathetically aroused, where actually, if you could have just let them run around on the lead line a little bit and move their feet, much like they would in a pasture, if something spooked them in a pasture, they don't go running and keep running. They'll run, so many feet and kind of look behind them and determine that, okay, this isn't so spooky. And then they'll reset their nervous system. So understanding the nervous system and how horses can reset, we can work with them. But sometimes if you have no knowledge at all and you're scared and the horse is scared and you're trying your best, and oftentimes that's an external locus of control and restraint, we get them not only do they feel threatened, they start to get panicked.
Dr. Peters, this is amazing. We have on this a real expert in managing large animal rescue. That's Dr. Rebecca Husted.
She is the go-to person. Rebecca is, I mean, she eats, breathes, lives this, teaches this. She is she's a national treasure. Actually, yeah, she's the one who's actually roll up the sleeves on the scene, knows what this is all about. So I'm just talking about the nervous system. She knows exactly what to do. I don't know.
So I'm
Are you
going
going
to
to
go
have her
ahead.
on?
Yes, she's on, and she's also a committee member for HHRF.
Oh,
So we're
great.
delighted to have her.
Great.
So I think given the time, we are going to go ahead and wrap this up. We will keep you posted on part 2. I think, Kathy and Pebbles, we can capture this chat, and we can also share those questions with Dr. Peters, because I think that feedback loop is helpful for you to know what are the questions that were generated. And that will also help us shape part 2.
And I want to thank all of you. And this really makes me feel really good about where we're going in the horse world, that this many people are interested and this many people want to learn. So pat yourself on the back. We're all in this together, and it's slowly moving in a very positive direction for us in the horse. So, so glad you're aboard on this whole thing. You folks are fantastic. I'm glad to talk to you.
Thank you very much. Thank you to everyone who attended and blew us out of the water with your attendance. We always appreciate your donations. Any communication. We're interested in hearing from everyone who attended. What other areas are you interested in gaining education? What are areas that you have questions for research? Because for HHRF, we are interested in applied research. We want to help produce or at least fund research that's going to matter to practitioners, people that are involved with horses. So this is a communication and a community, and we value your input along with the experts that we try to bring to you. Dr. Peters, thank you so much. We are definitely indebted to you. We look forward to building a longer term relationship with you. And I wish everyone a wonderful day and time with your horses, a chance to look at them through the lens of what you've learned this evening. Thank you.
Keep up the good work. You're doing wonderful work. Keep it up.
Thank you.